Now that miners are adding blocks to the blockchain that consist of transactions, we can add a function to the wallet class that calculates its balance based on a given blockchain. This will be the most complex and involved single function that we write. Overall, keep in mind that the idea is to calculate the balance for this wallet based on only the most recent outputs dedicated to it, since its most recent transaction on the blockchain. The concept becomes complex mostly because the output objects are within transaction objects, which themselves are within block objects that are within the chain. So it's that level of depth of storage that will require us to use additional methods to grab the actual data that we need for the balance calculation. So to start, let's add a calculate balance function right before the static blockchain wallet function to the wallet class. The calculate balance function will have one parameter, which is an incoming blockchain object to calculate for. And to begin, let's create a balance variable that is set to the current balance on this wallet. Next, we'll want to look at each transaction object that is contained within each of the blocks on the chain, meaning we'll want a transactions array that removes the added layer of the blocks and creates an overall array consisting of the entire history of transactions. So to start, we'll make a temporary variable, or rather a variable that is local to this function called transactions that is set to an empty array for now. And then we're going to run a for each loop on each block within the chain to look at the blocks one by one. The blocks consist of a list of transactions, so as we look at the block's data, we'll also run a second for each loop on the data of that block, which is the list of transactions. So first, we run a loop on the blockchain itself, and then we look at each block one at a time. Now, what do we do with that block? Well, we look at its data, and then we also run a for each loop on that, so that way we can look at one transaction at a time. And for each of these transactions, we'll call transaction.push transaction. Next, recall that our goal is to only sum up the output amounts addressed to this wallet after its most recent transaction. So we're also mainly interested in the transactions that were created by this specific wallet. Therefore, let's create an array of transactions whose input was created by this wallet, and we'll call this wallet input T's, T's standing for transactions. So our wallet input T's constant will soon be an array of wallet input transactions that are addressed and match this wallet's public key. To create that array of wallet input transactions, we can use the filter method on the existing array of transactions that we have now. So this transactions.filter will allow us to create a subset or smaller set of the transactions in this array, and will only return those transactions whose .input.address is equal to this .public key. So this should give us the transactions that were inputted by this wallet. With this array of input transactions for the wallet, now we're mainly interested in the most recent transaction that this wallet created. To find this recent input transaction, we can use the reduce function, which allows us to take a JavaScript array and reduce it down to one value based off of a maximum or minimum condition that we provide. The condition in this case will continually reduce the array to collections of objects or to the one object with the highest value for the timestamp, which is the number of milliseconds that have occurred since January 1st, 1970, since it's using the date.now function. All right, so we can create this recent input T to represent the recent input transaction for this wallet. And we're going to reduce down the wallet input T's that we filtered. And as we reduce it, and then we'll provide a callback function. First, we have a prev parameter and then a current parameter. So it's going to be looking at the input transactions 2 elements at a time in a pair. And then we decide to return one of these elements. And we're going to return the one whose timestamp is higher. So we'll do this with a ternary expression, and then we'll ask if prev.input.timestamp, if it's greater than the current.input.timestamp, and then we have the question mark to go to the cases of the ternary expression. then we'll return the previous element. Otherwise, we'll return the current element. So pairs of elements at a time through the input transactions, it will boil it down to the one whose timestamp is always higher, eventually getting to the one with the highest timestamp, and that should give us the most recent input transaction amongst this wallet input transactions list. Great. There's an important JavaScript implementation detail to consider though. When we reduce a function, we cannot reduce an array that may be empty. So if our wallet input transactions value ends up not finding any matching transactions, this value will be undefined. Therefore, let's surround the reduction of the wallet input transactions array with a check that only makes sure it runs the recent input t if the wallet input t's dot length is greater than 0. In other words, that it actually found values and it's not undefined. So we'll surround the reduction with a block that only runs if it matches that condition. With this found recent input transaction though, we can assume that this wallet's balance is the amount of whatever they specified as what they should result with the output object of this transaction. Meaning, transactions create an output objects which detail how much currency the wallet should end up with. So let's acknowledge that and set the balance to the amount within the recent input transaction that is dedicated to this wallet. So we'll look through the recent input t, we'll look through its output objects, and then we'll find the one that matches this address. So we'll look at each output one at a time, and then find the one whose output.address is equal to this .public key, and then we'll set the balance to the amount specified in that output object. All right, now that this balance is set to the correct amount from the recent input transaction, let's add up the rest of the currency that belongs to this wallet coming after that transaction. Every following output amount addressed to this wallet after the recent transaction will be added to the overall balance. So as such, we'll need a way to check if the transactions that we look through eventually were actually generated after the recent input. So what we can do is we can declare a start time variable above the if condition. So we'll let start time initially be 0. And in this case, we'll look through all transactions in order to find amounts. However, if we find a recent input, we only want to look through those that come after this input transaction. Therefore, we'll set the start time to the timestamp in the recent input transaction. So that will be recent input t.input.timestamp. And with this, we're prepared to look through each transaction output and add up the output amounts that match this public key coming after the start time variable. So let's run a transactions.forEach loop, which allows us to run code on each of the transactions. We'll go through one transaction object at a time. And again, we're only going to want to look for outputs if the transaction timestamp is bigger than our start time. So let's have an if condition that checks if transaction.input.timestamp is greater than start time. The reason why we set it to 0 is that if there's no wallet input transactions found, we want it to look through all the transactions and every timestamp will be valid because it'll be greater than 0. But if one is found, it'll only find the ones that are after the start time. Now, if the transaction passes this check, we'll look at each of its outputs. So this transaction.outputs, we're going to find an output one at a time. And then if the output.address matches this .public key, in other words, the output amount is dedicated to this current wallet, then we'll also add the output amount to the balance. So if this output address matches the public key of this wallet, add the output amount to the balance. And finally, after all of this calculation, we can return the balance. Excellent. That was quite an extensive single function. But to review, essentially we boil down the blockchain data to an array of transactions. Then we boil that down to those transactions that are devoted to this wallet's input. And then we find the one that is most recent from that. This allows us to then change the balance to the one dedicated in that specified amount as the result of the transaction, and likewise, it allows us to modify the start time so that way when we add up the outputs, we only add up those that have come after the most recent transaction. Great, that will give us the overall balance. Before we move on to testing the calculate balance function though, we'll want to use this calculate balance whenever we create a new transaction so that the wallet always has the most up-to-date balance whenever they're creating a new transaction. Great. Before we move on to testing this function though, we'll want to use this calculate balance function whenever we create a new transaction, so that way the wallet always has the most up-to-date balance. So let's get to that next.